Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a look at some hot off the press activities dealing with transformation graphing. My name is Mike Houston, and I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. And with us tonight is Tom Reardon. Tom spent 35 years in the classroom teaching just, I think, about everything. Right, Tom?
Yeah, it's about everything.
So, Tom, will you discuss our agenda for tonight?
Sure. So participants are going to experience brand spanking new activities for transformation graphing. Two of them were finished today and field tested today, by the way. You're going to get activities for both the 84 plus CE and TI-Nspire technology families. Play, investigate, explore, discover functions by observing patterns. Learn how to use the Family of Functions website. It contains over 250 videos with over 450 graphing examples, and obtain all new materials, 84 programs, TNS files, PDFs of student activities, teacher notes, and solutions. Also the link to the video series. And we're going to have a webinar drawing at the end.
Thanks so much, Tom. We're expecting large crowds. Your audio is muted. Feel free to send any questions to Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Tom, without further ado, it's all yours. Feel free to share your screen.
That was quick. Thank you. So again, 35 years at Fitch and 40 years at Youngstown State University. All the materials are at this website. I'll pause this for a minute. That will be up later, and it could even be put in the chat, I guess. But it's bit.ly/T3F OF 2021. Okay, so all the materials are there. I'll show those later, and that website as well. I'd like to start off with a quote, and I use this quote very often. It's probably my mantra. I'm convinced that students can learn in more ways than I know how to teach. Not that I've given up, I just keep looking for those extra ways. And this is from Stephen Reinhardt from an article from NCTM, I think in 2000. Never say anything a kid can say. So I said what we're going to do, but I'm going to be a little more specific here. Hope to accomplish this evening. Use technology to assist students to visualize and graph 15 of the key parent functions, and to explore and discover patterns of 6 different transformations. PIDE, that's my acronym that I like to use, PIDE. Now TI-84 technology, discover transformations using lists, use the Transform app to help students learn to graph by hand. And I'm going to show you programs that expedite setting up the calculator as a teaching and learning tool to save you and your students time in the classroom. TI-Nspire technology, discover transformations using sliders. TNS files also that expedite setting up the calculator and give you more time as a teaching and learning tool. Also, you'll be getting gifts. Those are what I call worksheets. I prefer the word gift. I have a gift for my students instead of a worksheet. The Family of Functions video series with over 250 videos and examples. Modular, only use what you need or what your students need, and that's going to be a prime focus in the second half. These are the parent functions and transformations that we decided were big deals. Hopefully your favorite parent function is there and your favorite transformation is there. And then we also have combinations of those transformations. And that'll be clear as we go along. So not in the chat, but there should be a poll right now. It looks like, do you use either the A84 or B, the Nspire? If you could just go make that vote right now. I'd like to have an idea of, are you 50-50? Is it more than one than the other? But I will be supplying materials for both platforms of calculators. So please vote in the poll. So on On the TI-84, I like to use a summary of transformation graphing using lists, and some of you already know this, so I apologize ahead of time if you already know this. But I made it a little bit different in that I created a program that sets up the calculator exactly the way I want to do it, and then let the students spend more time on the actual investigations. So I'm going to show you that program, and I'm going to show you the what it actually does. So let me go ahead and bring that up here. All right, so the name of the program, and this will be available to you also, is called TG Lifts for Transformational Graphing Lists. So I'm going to execute or run that program. And it says using lists, the parent function is going to be in black. And you see this white agitated circle. That means it's in pause mode, waiting for me to press enter to continue. Parent function Y1 is in black. And these are the numbers or values that are in list L1 and L2. And this is in 1 and Y2, Y3, Y4, which will be more important or more apparent as we go along. The colors are listed just for that as well. Enter to continue. All right, so with that, I'm going to go to y equals just to show you what's there. So the parent function will go in y1, and you can see as a teacher, I'm going to be talking about vertical transformations, vertical shifts, horizontal shifts, and dilations. And so let me go ahead and do the with y equals x. Let me go ahead and graph that. And you see the parent function, and here comes the family members, okay, and you can see even y equals x plus 0 kind of overlapped there in brown. And then let me pull that off so you can see that better, okay. And what I'm doing, I'm using the TI Smart View emulator software so that you can, and this is what I like to do when I'm teaching. If there's ever, as soon as I do a different screenshot, I pull it off so the students who are behind can get caught up. So that's for y equals x. Now I can also change that to look at y equals x squared. And now when I graph this, just by doing one simple change, I've got the y equals x squared as the parent, and then the family members, y equals x squared minus 2 minus 1 plus 0 plus 1 plus 2. And so now students can kind of see how that goes. And I would do this more as a review at the end than at the beginning, okay, so that they understand where this is coming from. But look how easily we can change that. I can just change this to the absolute value function. Let that be the parent function. And again, we're seeing all of the vertical shifts for that. So this, again, is another way of just having students see those vertical shifts. And I'm going to show you the square root only because I really like the square root function. Second, x squared, square root of x, and then graph. And see again, the parent in black, and then the family members in brown. So let me, now I've got a color on here. I don't want a color. So I don't want to annotate. Turn that off. There we go. Sorry about that. All right, so there's Y2. Now Y3, I'm still doing with lists. So now I go to Y equals, and there's a GIF that goes along with this and says turn off Y2 by pressing enter on the equal sign and turn on Y3. And so now what I can do is go ahead and do this family of functions, the square root, but shifting left and right. And so the students can talk about how it's going from left to right and recall that. And then I can also change that to, let's say, 2 to the x. Another one might be, a good one might be 2 to the x. And you can again see how it starts there and shifts left and right. And then finally, I'll go to Y4. As soon as this finishes, seems to be taking its time. And turn that on, go to there. And so I'll turn off Y3 and turn on Y4. And let me change that to maybe back to x squared again for our parent function. I think that's a little bit better for multiplying there. So now we can go ahead and graph y equals x squared and c equal y equals negative 2x squared, the opposite of x squared, 0. Oh, I think I have negative a half x squared in there, 0x squared, which is linear, of course. And we're getting that kind of spider looking idea going on here. And let me maybe move that over to the next page so we can see that and pull that off. And I can do that with several other functions to kind of see that. Now, you don't need to have the program to do this. You could also have your students do all of this preliminary work where they set the window to a square window, get the grid lines on, type this into Y1 through Y4, set the mode, put these in the list, and so on. So those are all things you can do. And I do have that sheet supplied for you right here, graphing transformations of function using list on the 8480 CE family. So that sheet is there if you would rather not do the program. But I worked with students today and they thought that was great that we got right into it without having to type all this stuff in. So let me stop there for a minute. Mike, any questions or comments I should know about?
I think there was just one question about whether you're going to be planning to use the CX2 cast tonight at all.
No, CAS will not play a role in this at all. It's the Nspire will, but not the CAS. Sorry about that if that was a thing that you would want. All right, so now I'd like to look at the transformation app on the 84, and then we'll look at sliders on Nspire. And I created another program to save time and energy called Family of Functions 7 Examples. So let me go ahead and run that program. And show you what that does. So parent function in black, the transform function will be in blue. See the white agitated circle there, press enter. And it tells the students in order to increase the value of a parameter, you press the right arrow, left arrow to decrease. It's important that they know that, not up or down. And you can see here that this is what the functions are that you can work with here. Now, I didn't do all 15 or 16 of the functions that we had. I thought this was enough to get us going. You also notice we have 2 generic piecewise functions here, and we'll talk about those quite a bit in a little bit. So I want to show you the linear, what the linear does here. So again, you run the program. Okay, I'm going to choose linear. And it reminds me right arrow increase, left arrow decrease. It says run the transform app and press graph twice. Those are the directions. So I'm going to go to apps, run the transform app and press graph once, twice. And there is y equals x. And you can see with the circle it's tracing on there. And it's immediately set up to look at y equals x plus some constant b. So again, right arrow increases b. And let me go ahead and pull that screenshot off. And then left arrow decreases b. And so students can start to play with this. Again, it's one of the key words I like to use, play with the mathematics. And I got that pretty much from George Polya. Let the students, have fun with the mathematics. And then from there, I can go ahead back to y equals and say, I don't want to do that one anymore. I want to do one where the coefficient of x changes. So I'm going to turn on this second y2 and still have the parent function there. And so when I press graph, I can see y equals x, and I've got parameter a times x. And again, increase a by pressing the right arrow and decrease a by pressing the left arrow. And let the students play with that and see what's going on. And then the third one, and there are directions for it on here, is to have students do the y equals mx plus b. But on the transform map, the only 4 letters you can use in the parameters are a, b, c, and d. So I'll put a plus b, alpha b here. And now when I press graph, the transformation app automatically realizes that a and b are parameters. And you can see right here, maybe these aren't the ones I want to start with. So I'd like to start with a being 1. And one nice thing is I can just type in 1. And then I can go down or up to get to the parameters and type in b equals 0. And then I can go ahead and, again, right increases b, left decreases b, and then move up to a, and then right increases a, and left decreases a. So again, all the program does is to have the students have the setup there for you. So there is a gift that worksheet that goes along with this. We'll tell them to run the program, do the app, press graph twice, reminds them to increase or decrease the values for B, and then play with this. And then notice what happens to the graph and to the equation, look for patterns. And then it asks them to actually draw by hand, because that is our goal, is to have students be able to draw these by hand, not just always use a calculator. Draw it, and then use the graph screen to check it. So just go ahead and have B be -6 and see if you're correct. And then it goes through the other ones, the changing values for A, explore those, try y equals 3x, then trying 2 parameters at once. And then it gives you one example and several others to try as well. So let me stop there for a minute and see if there are any questions so far there. Mike?
So I think this is more of a general question from Samuel, just asking that they're no longer using physical handheld calculators in their classrooms, but they're using the Chrome notebooks. And just if you had any ideas or suggestions, especially for some of these activities using that particular device.
All right, so I'm not sure if the programs can be preloaded onto Chromebooks. I can't remember that. That's not my thing. So I did email a person at TI, but I mean, they're off tonight, so I don't know if she'll get back to me. But if you can get a program on here, those programs that I wrote can go on there. If not, you could use the sheets that set it up and see how I set it up and do that manually. So thank you, Samuel, for your question. And so for your question, you get a virtual Pez. Thank you for that question. Sorry, I didn't have the answer you would want, though, like knowing the answer. All right, so there's also teacher notes that goes with these, okay? I do want to show the absolute value because I think the absolute value is one that's a pretty good one to see. It looks to me like looking at the poll, 29 of you have not told me if you're 84 or Nspire, so it's a 40 to 8, 84 Nspire. So, but I still will show both. Okay. So if I go back and rerun this program, and this time I'm going to go ahead and choose absolute value. Again, it says to run the transformation app and then press graph twice. And notice it's also set up for that absolute value plus a constant. So I can go ahead and just change the values of C by using the left and right arrow. And again, let the students discover what's going on there. And then I can do the same thing by doing the turning off Y1 and turning on Y2. And by the way, this is something that goes back, I did this on the 81, or was it the 82, I think, the 82. And so it's not a different thing about using lists to do transformations, but adding this so that everything's set up, that the window's set up, the grid's set up, and so on, to me, is a huge help. So now here, as I increase b x minus 1, absolute value of x minus 2, and so on. So you can see the absolute value. And then you can have, again, more than one parameter. If I go back to y equals, and I can go ahead and insert alpha A times that quantity, and then even have a plus C. And now when I put in that, I have all three parameters there. And I also really like the fact that you keep comparing it to the parent function so that you can see that. So if A equals 1, I'd prefer that. B equals 0 would be like how I'd like to start, so I type it. And C equals 0, I like the C to be 0 to start. I also will point out the setup. If you press graph, which is the key for setup, you can actually change the steps to, instead of 1, to be like a half. But it will change the step for all three parameters, not just for the one you're currently on. So that's the absolute value. And then the last one I want to show is like my favorite one right here, and that is the piecewise. So I'm going to go ahead and run that program one more time. And this time I'm going to choose piecewise 0, 1. There's two of them because I think it's important to do these a couple of times. And again, press graph twice. And so this is my funny looking piecewise function. It's created by a line, a parabola, and another line. And again, students can go ahead and say, what does it look like to have f of x plus c plus 2 of x plus 3? So I think that's very important that students are able to play with those, because the generic piecewise functions are used quite a bit on ACT and SAT tests. And the reason why those are used there are that it kind of makes it levels the playing field, because nobody's seen this function before, but yet they can still apply the transformations. And I remember as a student seeing these years ago, having difficulty with it, and I'm hoping that the technology can help view that. So again, you can go ahead and change it so it's all three parameters. By the way, you'll notice that my piecewise function is here. You can see it. If you needed to go ahead and change that, you could change that if you wanted to as well. Again, I could turn on that one, turn off this one, and have it shift left and right. All right, so that's it for the 84. I'd like to now switch gears to the Inspire. So let me go ahead and bring up the Inspire. And looks like I already have that on. So let me close out this. Let me close out this function here. And reopen it so that we can start clean. So while I'm doing that, Mike, I saw a couple things pop up on chat, but they disappeared right away. Anything there I should be answering?
Yeah, the one I was actually just about to answer about piecewise functions, and the question is, are they mainly used for high school students above Algebra 1?
I would say they're Algebra 2 and above. Yeah, I would say that.
I was actually going to chime in and say that's how I felt as well until I started using Inspire. And now, especially as the 84 has that same piecewise template, I started using them back in Algebra 1 whenever we are looking at domain and range, especially domain. It really helps students see, understand the concept of domain and domain restrictions. So I actually use it all the way down in Algebra 1.
Yeah, yeah. Okay, so that's a good point, and Mike, that would be Pez worthy. So, Mike, you earned a Pez tonight, and whoever asked the question, thank you for that question as well. So, for those of you who know, I give Pez when I'm in person, but I used to. I can't do that anymore because of COVID. So I've decided to use lifesavers and tell the students you're a lifesaver. So anyway, here's the Nspire. And those who've not seen Nspire, this might be a good idea for you to see this because this is a little bit more powerful than the 84 transformation app, in my opinion. So I'm going to go ahead and look at the linear here. Oh, by the way, these are the types of functions that are available. These are the ones I'm doing, the same ones that I had on the 84, okay? But let me go ahead and show the Nspire linear. And so I'm going to go on to page 2.1, and it explains what's going on, and I'll just leave that because we're going to talk about it. And you can see this is similar to what I had on the 84, except now you can see that I use since the slider is going vertically, up and down are what controls these. So I'll just press the up arrow. And not only does B change to 1, but the equation changes as well. And I just love that fact that you can see the equation and not have to, think, well, B is equal to 3. It's X plus B, X plus 3. You can see that. If I change it to a negative number like X minus 2, it's going to be read as X plus a negative 2. But I just think that's a really nice feature to be able to see that. I think someone asked, is Nspire allowed on the AP exam? The Nspire is allowed on every single exam. The only thing is CAS is not allowed on the ACT. But other than that, Nspire CAS can go on SAT and the AP Calculus exam. All right, if I go to the next page, now I'm going to be looking at M times X. And here, my slider is going left and right. It's going horizontally. So to increase, I would press the right arrow. And here I set it up so that the parameters are going to change by every 1/2. So let me pull that off, and you can see that this y equals 2.5x. Or I can go down and see like y equals negative 1/2 x. Okay. And then if I continue on to the next page, now I'll have both of them, MX and M and B, okay? And since one's going horizontally, that'll can be controlled by left and right, and the other one vertically is controlled by up and down. So I'm gonna go ahead and I'm gonna decrease B to -3 and increase or decrease M to 1/2. So you could kind of see that. And so I can go ahead and, by the way, I'm pulling these screenshots off in case if you're using Nspire and you do have the emulator software, you can pull the screenshots off like I did with TI-84 emulator. The only thing is I can't grab the screen. There's an imaginary border right along the outside of this that if you just click and hold, it'll pull off the screenshot. But I can't grab the screen because look what happens if I grab the screen. That's no good. We don't want to do that. It's this imaginary border that you pull it off. Okay, very powerful tool as far as I'm concerned. So let me show you the GIFs that go along with this, the worksheets that go along with this.
Hey, Tom, I lost sound.
Oh, am I back?
Doesn't look like you're there. You go. Yep, you're good.
Okay. All
I
right.
lost
Sorry
whenever
about
you were
that.
talking
Thanks for
about showing
coming.
everyone the worksheets.
Oh, okay. Yeah, so the worksheets, all the gifts, everything I've done is available on the website that I created, and I'll show that at the end. But you're anything I talk about, you're getting the TNS files, the 84 programs, the gifts, the worksheets, whatever you want to call them. So for this one right here, you'll notice I got 3 parameters here. So since I'm doing that, C is vertical. It's the only one that's vertical, so it's controlled by the vertical. But A and B, I have to actually click on the slider to have it do the slider I want. And so just be aware of that. And so here I have the equation y is equal to -1/2 times the quantity x minus 3 squared plus 3. So if I ask students to graph that, this would be a quick way for them to check it and see that, okay, that these are actually correct. 2 to the x, this is one of my favorite ones, 2 to the x. See what you think about this one. This is on page 20.2. Now, as I'm flashing through these, I'd like you to see all the other things. We've got absolute value here. We've got square root function, all the different translations that you can do and transformation due on square root. 2 to the x. So here's 2 to the x, and I want to go to the one that has all this stuff on 20.2. So here, if I wanted to, let's say, do this, I want to pull it down to, and let's say I want to shift it to the left one. And there's my graph, and I can go ahead and pull that off. And so this is y equals 2 to the x plus 1 power minus 2. Okay, and I can do all those different things there. Have A going to be negative. See how that there. But what I like about this is how I made sure that the asymptote was in it as well. Okay, I thought that was important that the asymptote was there, horizontal asymptote was there. And then again, my favorite, the generic piecewise function. This will look at the second one. We already saw the first one. And we'll take that all the way to, well, we'll just go to the last page, 28.2, where all of the parameters are there. Let me pull that off so you can see that. All the parameters are there, and they're all standard to start with. So let's say I wanted to have this go to the left 3 units, and I wanted it shifted down 4 units. Oops. Shifted down 4 units. And there's my graph and the equation. And again, the idea is to let students develop their own learning. Practice, do this with a technology, but then still be able to do it by hand. That's very important to me and hopefully to you as well. All right, so did that. And do I want to show the gifts? Yes, I want to show the gifts. So here is the piecewise one on the Nspire. And again, it just shows the students what it should look like as they're doing things, and then graph it by hand and ask them to check it using the technology. And so just kind of walks you through it. And then I had some room left at the end. So go ahead and try these. And again, these are really big on the ACT and SAT because no one's seen these functions before. And it's seeing if you truly understand the transformations. So with that, that takes me to the end of the Nspire 84 part. Now I want to look at the video series that TI has developed, Families of Functions. Before I do that, Mike, any questions that I should be aware of?
I think we're good.
Okay. Please ask if you've got them. I'll be, I'm glad to help you out with the answers if I find out. Let me see if I heard from anybody on that request there. No, haven't heard about the Chromebooks yet. All right, so if you've seen this before, apologize. Hopefully I'll show you something different. But this is a complete modular course, videos to help students called Families of Functions. It's a modular unit, meaning you only use what students need or want. You've got 250 videos, 450 examples. If you only need 3, those are the 3 you do. okay? We made it originally for remote learning, but it also can complement in-class learning now. A flipped classroom, ideal for a flipped classroom, or independent study or review is needed. So if you got a kid that's really sharp in Algebra 1 and say, hey, you want to learn about all these transformations? Here you go. So there are 15 parent functions. They're explained how to graph them and why they're shaped the way they are. It also does, so it has a longer video for each of the parent functions, and then a short one, a real quick one, around a minute long, that says, if you haven't done the cosine for a while, let me show you what that is, or y equals 2 to the x, or y equals e to the x, or whatever. Why the transformations affect these parent functions and how to graph these. Using dances or tables, and I'll explain what I mean by dances. These are the transformations: horizontal shifts, opposites of functions, vertical shifts, vertical stretch and shrinks or dilations, horizontal compressions or expansions, okay? And also f at the opposite of x, besides the opposite of f at x, two different things usually. Free and modular. And again, how you can use this is an online course. Learn at their own pace. How ideal is that? Okay, learn at their own pace. And it's independent of any graphing technology you're using. If you're using an 84 Nspire or some other thing, you don't need to be using them. Okay, they're independent of that graphing technology. So again, these are the 15 parent functions plus one created piecewise function. Hopefully your favorite ones are in there. If it isn't, let me know and I'll see about maybe adding that. So can you find them on the TI page? Yes, I will give you a link directly to that page, but they are on TI's page. I'll take you there in a little bit. I want to show you what's there first. So the linear one also talks about slope because slope is such a big deal, okay? And I do want to have a quick thank you to the teachers who've helped with this project. Curtis Brown, my helper at TI, and then teachers all over the United States who have field tested these or evaluated or had their students evaluate them. So thank you for that. Different presentation. I've spent over 500 hours creating these materials to help you and your students teach or learn how to graph the parent functions of transformations. And I don't say 500 hours lightly. I mean, think about that. Long time. It took over a year. There's mathematics and pedagogy in these videos. I'm going to be showing you what materials are available and how to access these by you and your students. And they're meant to be how a teacher like me would teach these concepts, allowing the students to pause and try ideas, okay? Now, I will tell you the main complaint we hear from students that the videos are too long. And so when I worked with them, I said, okay, what can I take out of them? And they most of the time came back and said, well, if you took this out, I wouldn't understand it. So they don't like that they're long, but it's like a necessary evil, I think. So first of all, there's how to graph each parent function, and the parent functions are labeled with a P only for reference. And so 0, 1P would be how to graph y equals x squared. 0, 2P would be how to graph y equals the absolute value of x, and so on. So they're about 5 to 9 minutes each. That would be like if you've never ever graphed one of these functions, this would be your first introduction to that. Illustrate how to graph it and why the curve is shaped as it is. Key terms are discussed like intercepts, asymptotes, domain and range are included, and where applicable, a practical application of the graph of the parent function. So something you would do your first time, except I'm doing it. So the numbers, again, are just for easy reference. Do not memorize them. So I do want to show one of these. I want to show the quadratic, how you graph up the quadratic 0, 1P. And I'm not going to play the video. I would prefer just to walk you through it so I can go faster than the video would. And these are the slides that I use to create it, okay? So how to graph y equals x squared using the parabola dance with proper vocabulary. I remind students they need graph paper and a pencil. We want to do this by hand, and this is part of the Family of Functions series. If you don't have graph paper, you can download graph paper right from TI's website. And so we're starting here. So y equals x squared, I'd start with a table. And these are the 7 values that I would like you to use for X. Those are like the big 7, I call them. Checking what time I'm here. And so I'd ask them, I'll pause to complete the table. And so we'll go ahead and put in those values. They've completed the table. And now I'm ready to plot them one by one. So 3, 9, 2, 4, 1, 1, and so on. And so I'm plotting those 7 points so they can see the outline of the curve. And I want them to notice something. Pause and say, do you notice something, both in the table and in the graph? And I'll give them hints by using color here and here, and color here and here. Are you noticing? Well, you notice it because you already know it, but I'm hoping that they'll notice that this is called symmetry and that the graph is symmetric about the y-axis of the line x equals 0. Now, some students will say, is this a V shape? And that's a good question. Is it a V shape? So to help do that, I decided, how about if we try 2 more values for x? And so now I have to square a half, and contrary to some students, it is a fourth, not 1. And I'll square negative 1/2 and also get a fourth. And so I'll plot those 2 points, 1/2 a quarter and negative 1/2 a quarter. And you can see it's not a V shape. It is more of a U shape, and we call it a parabola when we connect the points. Again, I'm going faster than the video would, and you could pause the video, and you really can't pause me, sorry. Terminology, this is the vertex normally at the origin, that we do have this mirror line that we call an axis of symmetry. And again, I want to emphasize that, each point's on the same side or opposite sides of that axis of symmetry, but the same distance away. The parabola dance, well, we start off at the origin because 0 squared is 0. And then from the vertex, right 1 up 1 because 1 squared is 1. Right 2 up 4, 2 squared is 4, and right 3 up 9, 3 squared is 9. I could use the symmetry idea, or you could do left 1 up 1, left 2 up 4, and left 3 up 9, because the quantity of negative 3 squared is 9. So that's what we mean by the dance. And each of the parent functions has what I call a dance to kind of remember how to graph it from certain reference points. Again, notice the symmetry about the y-axis. Big on students seeing that. Domain and range. So for the domain, if I go ahead and draw in the green x-axis, I can see I have y coordinates above all of those or on it. So it's all real numbers or a script R. And the range starts at 0 and everything greater than that. So it's real numbers greater than or equal to 0. And we use this kind of set notation to describe that. Where could you see a parabola? No, it's not the Bellagio. It is the World War II Museum Memorial in Washington, D.C. So that's just a quick view of how to graph a parabola, and hopefully that would be good enough for your students, or more than enough for your students, I should say, not just good enough. So let me stop. Mike, anything I should know? Anything came up? Do I still have people out there?
Yep, a couple. I think a good question came in from Sharon. How do you choose to deal with the fact that the x plus b is not only a vertical move, it's also a horizontal move?
Okay, so that is not discussed in it. That would be left for the teacher to do that. Okay. I did not touch that at all. There are several things that I would have liked to have included, but I tried to keep it pretty much generic. So that would be a good teacher thing. So thank you for that suggestion. So whoever that was, you earned a virtual Pez. Thank you. Back. Go. All right, so then there are also quick graphs of the parent functions. They're about 1 to 2 minutes long. They illustrate how to graph the parent function, but the key word there is quickly. You've already seen it. They just need a quick review of it. And then there's graphs or there are videos of each of the 6 transformations that are explained, and these are the 6 here. Hopefully these are all ones that you would want to see. And I think this is the hardest one, by the way, horizontal compressions and expansions. They're between 8 and 20 minutes long, and the students really complained about that. But when it comes to trying to explain horizontal stretch and shrink, I can't do it in 5 minutes. Okay, I can't do any of them in 5 minutes and do it justice. So hopefully they'll go along with that. So these are examples of what I mean by a dilation or a vertical shift or horizontal shift and so on, so that you can kind of see what we're talking about here. We suggest that before you do any transformations, you do the transformation in general. Okay, for example, if you're going to do this function here, vertical shifts the generic vertical shifts video should have been watched. Otherwise, it won't make a whole lot of sense. Again, these are what it looks like on the website. You can see they created some cool looking icons to discuss those. We have several combinations of transformations, and we decided to do that with a simple one, a moderate, and a complex. And this would be an example of a simple, a moderate, and a complex. You can see they are getting more complicated. So how do you get these materials and a list of all the equations and graphs on videos? Well, that's a good question. This is the quick way to get there. There's a link on the website that I created that will take you there. I'll also show you how to get there from TI's website. Okay. I want to show you more about what's there before we actually go there. But this is the landing page or the home page. There's a quick video kind of explaining about this page here. Again, explain what we do here. Watch the video to get started, but download the quick reference guide for course videos and materials. If you heard nothing else or remember nothing else from about tonight, this is the thing. Download the quick reference guide, view it, see if this would work for your students. If it does, great. If not, don't use it, okay? So I call this essential. I'm serious. This PDF is essential. I'll show you that in a few minutes. Also, these are just some of the icons they use, the parent functions, the equal sign is how to graph it, a clock for quick. Oh, geez, I didn't mean to jump there. Sorry about that. One bad thing about technology is when you hit the wrong button. All right, so the quick reference guide, essential, take you there. Gotcha. Okay, so these are the transformations, and hopefully those icons kind of make sense, or the letters will make sense for you. And then the combinations of them. This is what it looks like on the web page. These are 6 of the parent functions, 6 more of the parent functions, and then the rest of them. And notice we did add sine and cosine. Let's look at quadratic. If I click on quadratic, it takes me to the page where I can click on this right here or on the equal sign, and it will play the video of the parent function. I could click on the clock and it'll show me the graph of the quick parent function. I can download graph paper by clicking there. I can view any of the transformations on any page. So if I'm not sure, what is it, shifts up and down, horizontal shifts, I can play those videos from any one of the parent pages. And then below that are the quick videos for the transformations. And notice you've got an arrow here to show you more of them, okay? And so there's usually about 15 videos, a how-to, a quick, and then 13 transformations, including simple, moderate, and complex. So let's go to the website and see it. I'll show you one way of getting there is if you go to education.ti.com, and this is one way of getting there. It's under resources, and under resources, there's a resource called Family of Functions. Okay, so under Texas Instruments Resources, Families of Functions, and it takes you to the landing page, the home page. There's that video, okay? But again, the key thing to me is the quick reference guide. So if you click on the quick reference guide right here, So it'll say it's downloading. And so here it is. I can go ahead and open the file. And so this is where, again, the main thing to me. I hope this works for you. Okay. So there are 22 pages. So this is why I would not have you print it out. Plus, there's all these live links on it. So the first page is just kind of it shows what all the parent functions are. And I made these all hot links so that if you're too lazy to go to, for example, you want to go to y equals 1 over x, a reciprocal function, just click on page 8 and it takes you to the reciprocal function. Okay. And it shows you what functions are there. But let me just start at the beginning and go maybe look at these from the beginning. So the first page shows those. The second page shows links to the transformations in general. Okay. And you'll notice each of them have two links, a YouTube link and a bit.ly link. The YouTube link, of course, are obvious or are awful to look at. The bit.lys all have the same pattern, which I'll explain in a little bit. But let's look at first linear, because I think a lot of you teach linear relations and slope. Okay. So we have examples, and now you try one. So the first one is standard form. We're calling standard form for the linear equation. And we go 2x plus 3y equals 18 in great detail. And then we say, now you try one, okay, like a self-assessment. We also have a quick, here's our quick explanation, quick video. Here's slope intercept. Here is point slope. Here is x equals a constant, y equals a constant. And then we also have combinations of them. And in fact, if you're teaching linear functions right now and how to graph them, you could take your students to this page and say, which of these can't you do? Whichever one you can't do, play that video until you learn how to do that. I mean, that's the idea. Look at the example. If you can do them, don't waste your time. But if you can't, do them. So again, here's a collection of them. And then slope, again, is such a big deal. These are the 4 or 6 videos I created on slope. And this is exactly how I taught it since I started teaching back in 1974. I know many of you were not born then, but that's okay. So one video is what slope means in the 4 flavors of slope: positive, negative, 0, undefined. Calculate slope from graphs. The students need to be able to do that. From tables, derive the slope formula. Calculate the slope using the slope formula, draw lines with given slope. So there's a video on each one of those. And then the squaring function, again, the parent, the quick version of it, and then the vertical transformations, horizontal transformations, dilations, horizontal compressions and expansions, opposite of a function, the f of the opposite of x, and then combinations, simple, moderate, complex. Now, again, getting towards the end here. Again, let me explain about these links here. All of the links start with bit.ly / TI-21 for year 2021, FOF for families of functions, and then the last digits are just this code. So if you can't copy the links and give them to your students, then you can just say, I want you to do the bit.ly ones that ends in 01HB, okay, or the ones that end 01CA or something like that. So those are the quadratics. These are the absolute values. I mean, again, I hope you look at that tonight and see whether this is something you can use. Give them to your students. Say, look, whatever you need to learn, go ahead and learn it. Okay, so hopefully this is of value to you and to your students. All right, what else do we got? So again, the download the quick reference. Oh, this is the website that takes you directly to that home page, bit.ly / FOF capital TI. Okay, so and also the link is at the website that I'm going to show you shortly. All right. Again, the quick reference guide, can't emphasize that enough. Kind of showed this already. I showed that these are the same videos. It doesn't matter which link you use, they'll go both places. But this also explains how to do that. Absolute value. And again, as mentioned before, ACT and SAT love the piecewise functions. I showed you the actual PDF. The linear relations showed you all the stuff that goes there. Standard form, slope intercept, point slope. y equals a constant, x equals a constant. And the slope videos, I think I've already highlighted those, so I'll just kind of go through that quickly. And then these are the 15, 13 extra ones that go with it. Kind of running out of time. I'm not going to show you the y equals cosine x quickly. You can watch that if you want, because we're getting kind of low on time. So let me just show you, this is the picture of the website that I created. And on the left side is the families of functions stuff. And the right-hand side are the 84 and Nspire materials, okay? So if you click on here, that'll take you to the homepage for family of functions. This will take you right to the quick reference guide and let you download it, and then you just open it. Again, I would not print it. I would just, use it as a electronic copy. The PDF of the slides of the presentation will be here shortly. Some people have usually asked me the link for the TI-84 tips. So that's a whole nother thing there that you can go to. The 84 materials, the program, the linear, the quadratic, the piecewise, all of those are there, student and teacher. And then the transformation using lists, that the materials are here. But if you don't want to just pick and choose, you can get all the 84s in one zip folder to download, and all the Nspire materials in one download there, okay? Let me just show you what it looks like live so you understand that I'm not teasing you. So this is the website I created. It has a nice title, has my email address. If you have any comments or suggestions, would love to hear pros and cons. I'd like to make this better if I can. Again, all the families of functions stuff is here. The 84 materials here, Nspire materials here. They're all there. This slides will be there in a little bit. So hopefully by tomorrow morning. And let's see. Preview of coming attractions. I'll be doing another T-Cube webinar on January 18th. Please mark your calendars. Mathematics and activities dealing with the winter sports events that are occurring in Beijing, China in February 2022. Now, this begins with an O and rhymes with Olympics. I'm not allowed to say that, and I'm not allowed to say something else, so I have to describe it. For some reason, they're very picky, these people that have the sports events in Beijing, that we do that. So, but hopefully you know what I'm talking about. So with that, I will turn this back over to Michael. Mike, any other final questions or comments I should know about?
I didn't see any as I was scrolling through, so I think we're good.
Good.
As Tom mentioned, though, if you do have any last-minute questions, or if I happen to miss a question, feel free to reach out to Tom. I know he'd be happy to hear from you. As mentioned earlier, we are giving away to one lucky winner a TI graphing calculator tonight, and tonight's lucky winner is Michael Denninger. So, Michael, congratulations. We'll be in touch over the coming weeks to give you a little more information about that and to get some information from you. To download a certificate of attendance as well as the documents, go ahead and click the link in the chat window. Tom's documents link, the bit.ly, is also included in my documents link as well, so in case you happen to miss that earlier, feel free to get it from there. If these links aren't working for you for any reason, just hang tight. You automatically get a follow-up email in a couple days, and that follow-up email will contain links to the certificate, the documents, and the recording as well. And if you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. If anything else comes up after the webinar tonight, it's not specific to Tom, feel free to give us a call or drop us an email, 1-800-TI-CARES or ti-cares@ti.com. We'd love to hear from you. Finally, as you leave the webinar, a brief survey will automatically appear in your browser. Your feedback guides us and guides Tom as we plan future online events. So if there's things, again, that you'd like to see that you haven't seen yet, feel free to share that in that survey. Tom is one of the people that I think does get some information from that survey as well. And so it's great having him on board helping create so many of these activities. So with that, Tom, thanks so much for everything you put together for tonight.
Thanks for having me, Mike.
Always. And thanks everyone for joining us. We hope to see you back online next week. Have a great night. Stay safe.